All right, so let's go ahead and take a look at our homework. Um, Again, I'm going to kind of reassign the same exact type of problem so that way you get a chance to do these and actually understand them, hopefully. Um, of course, the first question was just the book, and that didn't really do a whole lot, which is why I wanted to make a video of the lesson. Then I want to make sure I go over these as we're doing them. Um, the first couple were like this. Describe how the graph of the function f of x equals 2 over x minus 3 can be obtained by transforming the graph to the reciprocal function g of x equals 1 over x. Identify horizontal vertical asymptotes and use limits to describe this corresponding behavior. Sketch the graph of the function. Okay, so here's the problem that we have. We're going to graph this. Okay, but first of all, you guys should be able to tell me right now what the asymptotes are. If I take a look at this problem right here, I'm just going to copy this and put it into this real quick so we can. So look at what it's asking. You should be able to graph this, okay? But you don't need to. What's the vertical asymptote here? Vertical. Holy moly. Let's spell that right. Asymptote is what makes the denominator equal to 0. Well, set x minus 3 equal to 0. I'm going to add 3, and that gives me x is equal to 3. So I have a vertical asymptote at 3. Well, what does that do to the original graph then? It's going to move it to the right 3 units. So which one of these says the reciprocal shifted to the right 3 units? So it's got to be this one. It's only one that has it, right? And then it says vertically stretched by a factor of 2. Well, again, this right here is my vertical stretch. So it's going to be a vertical stretch of 2. So it's going to be D when I go to that problem. Okay, so go here, vertical asymptote at 3. That tells me it goes to the right 3 units. This is the only one that says it's shifted to the right 3 units. Check my answer. Good, well done. Then it says select the corresponding, the correct choice for the vertical asymptote, and that is x is equal to, what did we say? X equals 3. Okay, so check the answer. Good. Okay, select the correct choice for the horizontal asymptote. Now again, here's where we have to look at what's the degree of the top. The degree is 0. What's the degree of the bottom? The degree is 1. The degree of the top is less than the degree of the bottom, then it's automatically at y equals 0. That's why there was no shift up or down, because the horizontal asymptote was at y equals 0. Okay, and then choose the graph below. So you should be able to go to no, I don't want that. I want to go to Desmos. Do I have it open or not? No. Okay. So I want to go to Desmos and I want to put in, what was it? 2 over x minus 3. Look, you can just look at the graph. Okay. Well, again, when you look at this, make sure you're paying attention to which one of these has a vertical asymptote at x equals 3. So it's either got to be B or C, right? And then now, which way can we tell? Well, if you look at the graph, it's going on the left down, on the right up. So left down, it's either B or C. On the left, it's going down. Well, this is the only one that's going down, so it's B. Okay. Um, so again, use Desmos to help yourself out. Check answer. Good. We got that one right. So then we have another problem that is again asking us to explain all of these. So you should be able to tell me just by looking at this, is my hope, what these shifts are. Okay, so let's go ahead and talk about this so I can write some stuff down. So again, take a look at this problem. There we go. What is the vertical asymptote? Right here, what will make the denominator equal to 0? Well, that would be at x equals -2. And then, so this is my vertical asymptote. Just going to put VA. And what's my horizontal asymptote? Y equals, look at this, 4, same degree, degree 1, they're the same, so I divide, y equals 4. Okay, so again, what would that look like? Here's the horizontal asymptote. There's the horizontal, there's the vertical. Well, what did the graph do? It went up 4, it went left 2. So it went up 4, so it translates to the right 2. No. Vertically shrink. I don't know about shrinking yet. Reflect about the, I don't know about that, but I know that it translates up 4, so it'd be F, and it translates to the left 2. So I know just by getting those two, I can answer these two questions. Now, how do we get the translation? Well, we have to divide this. X plus 2 on the outside, 4x minus 1 on the inside. What number times x equals 4x? Well, that would be 4. 4 times x is 4x. 4 times 2 is 8. I'm going to change the sign. That's going to give me a negative 9. So again, how would I write this? I would say 4 minus 9 f of x plus 2. This is my horizontal asymptote right here. This is my vertical asymptote. This is my shift and vertical stretch. So this is a vertical stretch by a factor of 9, and it reflects about the x-axis. So when I go back to that problem, again, how did I get negative 9? It's just the remainder. All it is the remainder. The remainder tells me the vertical stretch, and it tells me whether or not it flips or not. So go back to that problem, and we said that it reflects about the x-axis. We said it translates to the left 2, up 4, and has a vertical stretch by 9, right? Just by doing all these. So now identify the horizontal asymptote of the graph. Well, what was the horizontal asymptote? It was y. We're typing equation. Y equals 4. Again, how did I get that? Same degree on top and bottom. Divide. Okay. Identify the vertical asymptote. What makes the denominator equal to 0? Type the equation. X equals negative 2. Good. Okay. Now choose the graph. So I would go and I would graph this. I'm not going to graph this right now. I might get it wrong, but I know that it's x plus 2. Actually, it's not. I'm not going to get it wrong. So negative 2 and up 4. So it looks like this one, and then it flips. So it's B. And again, you can plug this into Desmos and graph it if you didn't know it was B. Okay. So same exact type of problem here. Just make sure when you divide this one, you set it up the correct way. It should be negative 3x plus 2 to be able to find all the remainder to get the vertical stretch and the compression. Okay, and whether or not it flips. So let's take a look at the next question. Okay, good. Talk about the limit based on the graph shown. So here's the graph. They're asking us when x is equal to 1 from the left. What is the graph doing? It's going up to positive infinity. Really simple question. Okay. Now, what is it doing as we look at negative 2? Again, from the left, what is the graph doing? It's going down, right? From the left. Negative 2 is right here. From the left, it's going down. So I would put negative infinity. Okay, find the horizontal, vertical asymptotes. Use limits to describe the corresponding behavior. So we're going to go over this problem together. Okay, the horizontal asymptote. Select the correct answer below. If necessary, fill in the boxes to complete your choice. Make sure you pay attention to this. Degree 2, I divide. The function has one horizontal asymptote. Type an equation at y equals 5. Okay, where did I get y equals 5? I divided 5 over 1. Those are the leading coefficients. Okay. Says use limits to describe the corresponding behavior. Select it. So this is where I was talking about. This is asking the limit. There is one horizontal asymptote. What is that horizontal asymptote? It's at 5. As x approaches, let's see, how did I do this? So as x approaches negative infinity, what does y equal? That's my asymptote. As x approaches positive infinity, because it's going to the right, what does y equal? And that's my asymptote. So again, I put negative infinity and positive infinity because that tells me the graph's going left and right, and I put what the asymptote is. Okay. Now for this one, says find the vertical asymptote. What's the vertical asymptote? What's the value that makes the denominator equal to 0? Well, if you were to graph this, you would see that there is no vertical asymptote because there's no value that will make the denominator equal to 0. If I plug in any number here, it's going to be positive. If I add 4 to that, it will never equal 0. So there is no vertical asymptote. So again, the function has no vertical asymptote, so I don't have to fill in this stuff up here. Okay. Okay, so a new problem says find the horizontal vertical asymptote. So we'll go through this one again. Select the correct choice. What's the degree of the top? 1. Degree of the bottom? 2. Degree is less than the bottom, so that the function has automatically 1 horizontal asymptote. But I want to find the vertical asymptote. So this is talking vertical asymptotes first. All right, so find the horizontal vertical asymptotes. Saw quite a few of us miss this, so let's go through this problem on this. So again, how do I find vertical asymptotes? I need to set the denominator equal to 0 and factor. So I'm going to set x squared minus x equal to 0. I can take out an x. What are the two zeros? X equals 0. X equals 1. So the function has two vertical asymptotes. Make sure you pay attention to this. It says the function has two vertical asymptotes. The leftmost asymptote would be 0, and the rightmost would be 1. Okay, type equation, so I have to put x equals. So go back to the problem. There's two vertical asymptotes. I've got x equals 0, and x is equal to 1. All right, so check my answer. Check it. Nice work. Good. Now it's going to ask you select choice for horizontal asymptote. Well, again, degree of the top's less than the degree of the bottom. So therefore, this has one horizontal asymptote, and that horizontal asymptote is at y equals 0. Okay. Now it says, this is important here. Okay. The limit as x approaches 0 to the left. I need to graph this. Okay. 5x plus 3. So I'm going to graph this. No, not that one. And on the bottom, it was what? X squared minus x. That's right. Look, first of all, notice all these different parts of the graph that you can't see if you just leave it at the home function. Okay, so this is saying as x approaches 0, which would be here on the left, right? That was what the homework problem was saying. So let me make sure I read this correct. Okay, the limit as x approaches 0 on the left. So what is this graph doing? On the left, it's going up to positive infinity. So we would put positive infinity. Positive infinity. Okay, now it says as x on the right. So what is this graph doing as we go to the right to 0? Well, hold on a second. There was a graph down here, wasn't there? This is the closest value to x equals 0. What is it doing? It's going down to negative infinity. So that would be a negative infinity. Not up here. Remember, this is the other asymptote at 1. So we're looking at it here to the right, which is this value right in here. It's going to negative infinity. So negative infinity. Okay, it's going to ask now about 1. What's it doing from 1 to the left? So again, go back to the graph. 1 to the left. Well, here's 1. Here's to the left. What's it doing? It's going to negative infinity. And then 1 to the right, it's going to ask. 1 to the right. Well, here's 1 to the right. It's going where? It's going up. So that would be positive infinity. Positive infinity. Good. Check answer. Good. Now it's going to talk about the horizontal asymptote. Well, if you look at this graph, as f of x goes to negative infinity, what's it doing? Remember the horizontal asymptote 0? So as it's going to the left, it's going to 0. As it's going to the right, it's going to 0. So for both of those, it's going to be 0. If my horizontal asymptote was anything different, then it would just be that number, whatever the horizontal asymptote is. Okay. I think there was definitely some confusion with that. But that should help clear that stuff up. Okay, so now find the horizontal asymptote, select the correct. The last couple questions have a lot of parts with this. It says, find the asymptotes and intercepts of the function and graph the function. So here we go, x minus 1 over x squared minus x minus 30. So I'm going to go ahead and put this down on this so I can write on it. So let's just go ahead and find the asymptotes. Right. Well, again, look at the degree of the top. It's 1. The degree of the bottom, it's 2. My horizontal asymptote is y equals 0. My vertical asymptote, I'm going to set x squared minus x minus 30 equal to 0. Solve it. This is factorable. What two numbers multiply to negative 30 and add to negative 1? It'd be x minus 6, x plus 5, and then now I use the zero product property. So right there are my two vertical asymptotes. Okay, so let's go back and answer the questions here. It says find the asymptotes, find the horizontal asymptote. The function has it has one horizontal asymptote. The equation is y equals 0. Answer, got it. Okay, says find the vertical asymptotes. The function has two vertical asymptotes. Those vertical asymptotes were, again, if we went back and look at our work, at negative 5 and 6. So make sure you pay attention to this. It says the leftmost. So it would be at x equals negative 5 and x equals 6. Okay. Then it asks for find the x-intercepts. So find the x-intercept. I got to graph this. Okay. Find the x-intercepts. I go back and I graph this. What was it? X minus 1. Well, that was x squared minus x minus 30. And this was x, what was it when I say x minus 1? Sure that is correct. Yeah, x minus 1. Okay, so if we go back and look at the graph, here's the graph. It's asking for the x and y intercepts, right? Well, look, it labels them right there. Which one of these is the x-intercept? The one that crosses the x-axis, that would be this one right here. So it's at the order pair 1 comma 0. Make sure you pay attention to what it's asking for. It says type an integer or fraction. So it just wants the number. It doesn't want it as an ordered pair. Okay. And then the y-intercepts, if I go back to this, the y-intercept was 0.033. Now here is where this kind of I'm going to understand if you get this wrong, because if I want this to be a fraction and I put in 0.033 and I click fraction, it tells me 33 over 1,000. I can almost guarantee you this won't be the right answer in Pearson. Um, so if I go back here and I put in 33 over 1,000, it's going to tell me it's wrong. But this is what Desmos gives us. So again, it's probably something that's way smaller than this. 0.033 is probably like 1/2 over 27 or something like that. I don't care if you get this wrong. Just make sure you know that on a test, I would accept that 1 over 30. Okay. I mean, it rounds, Desmos rounds for us. So, and then graph it. So take a look at what the graph looks like. Left down, up right, and then the little funky thing in the middle. So the only one that has the little funky thing in the middle is this one, right? Or C, but make sure you pay attention that it goes to the down and to the right on the right, down and to the right on the right. So there's number 8. Number 9, same exact type of problem. I want to look at one that has a different, actually, you know what? No, I'm going to do this one. 3 over x cubed minus, so we're going to graph this. 3 over x cubed minus x. All right, so if we take a look at this, it's asking for all of the intercepts, right? Does this have any intercepts at all? There are no x-intercepts. Are there y-intercepts? No. And here's how I know. If I set this equal to 0, the denominator, I get x squared. So I've got this, right? 3 over x cubed minus x. If I set the denominator equal to 0 and solve it, here's all my zeros. 0, -1, 1. This means that it's never going to cross at 0 because I have a vertical asymptote there. So if I go back to that problem, I'm going to say there are no intercepts because that graph did not cross anywhere. Okay. So then it says the function has three vertical asymptotes. Does it have three vertical asymptotes? Yes, it does. At what? -1, 0, and 1. This -1. The equation for the leftmost is x equals -1, x equals 0, and x equals +1. And then the horizontal asymptote, degrees less than, so that would be y equals 0. All right, take a look at the graph. I'm not going to mess with the graph too much. I want to get on to another problem. I don't know. I think it looks something like it's either B or C. All right, go with B. You would check Desmos. So I'm not going to mess with it. There we go. So let's look at same thing here. Okay, so put this problem in. This one, there actually are going to be intercepts. So this is the last problem. I'm just going to graph it real quick and show you how to enter the intercepts. Then the rest of it you can do 2x squared plus x minus 2. 2x squared plus x minus 2 over x squared minus 1. All right, so here's the graph. Now this one has x-intercept, and a y-intercept. So it wants us to look at the way that we enter this. It says to just enter them, right? It says there are intercepts. It says type an ordered pair using integers or decimals. So I can actually use the decimals here. Okay. Round to 3 decimals. So -1, -1.2, what was it, 81? Yep, 281, comma, 0.781, comma 0. Those are my x-intercepts. And now the y-intercept is 0, comma 2. So for this one, you can just enter in the decimals, which is what I like. Uh-oh, what did I screw up? Hold on. I'm not sure what I typed in there. What did I type in? All right. So take a look at what there. Oh, I didn't put the 0. That's why. I didn't make this as 1.2810. So make sure you type it in there correct. I can't imagine they would mark 0 too wrong because I didn't round to 3 places. But that's the homework. Hopefully you're looking at these and you're able to complete these problems now.